and welcome to the video. In this video we're going to talk through the method of multiplying and dividing fractions. Very common exam questions when you go through your tests and when you approach your exams. We're going to start with looking at some multiplication questions. I'll go through a few examples, and then nearer the end of the video there'll be some tasks for you to have a go at. So this is a very typical question. 2/3 multiplied by 4/5. When we're multiplying fractions, it's not like adding and subtracting fractions where we need to have a common denominator. We don't need to change these fractions to have a common denominator like we do with adding and subtracting. For a multiplication question, we can simply multiply the numerators, the numbers on the top of the fraction, and we can multiply the denominators, the numbers on the bottom of the fraction. So I'm just going to go ahead and do that. I'm going to multiply my numerators, which is going to give me 2 times 4, and I'm going to multiply my denominators, 3 times 5. That's going to leave me with 8/15. So when I multiply 2/3 by 4/5, my answer is 8/15. At this stage, if it was possible to simplify, then I would go ahead and simplify. But for this answer in particular, we can't simplify. So 2/3 times 4/5 is 8/15. Have a look at another example. So again, we're going to use the exact same method. I'm going to go ahead and multiply the numerators, 3 multiplied by 4. And I'm also going to multiply the denominators, 4 multiplied by 5. So there's the calculations I'm going ahead and doing. 3 times 4 is going to give me 12, and 4 times 5 is going to give me 20. So I have a result of 12/20, 12/20. However, this time my final answer can be simplified. They are both divisible by 4. How many 4s are in 12 is 3, and how many 4s are in 20 is 5. So I've just went ahead and simplified my answer into its simplest terms, 3/5. So 3/4 times 4/5 is 3/5. Okay, so in this example, we're multiplying an integer, a whole number, by a fraction. So I'm doing 3 times 4/5. When I get a question like this, again, a very common exam question, I like to try and be consistent with the previous methods on the last few slides. So what I'm going to do is I'm going to change 3 into a fraction. So I'm going to present it as a top-heavy fraction, an improper fraction. So I've just rewrote my question slightly. Instead of 3 as an integer, I've presented it as a top-heavy fraction. So how many 1s are in 3 would be 3. So any integer can be presented as a top-heavy fraction by making it a fraction over a denominator of 1. And now I've got a very similar question to what I had on the previous few slides. So I can go ahead and do 3 times 4 for my numerators, and also 1 times 5 for my denominators. So that's the calculation I'm going to go ahead and do. There's my multiplication for the numerators. There's my multiplication for the denominators. 3 times 4 gives me 12, and 1 times 5 gives me 5. So 3 times 4/5 is 12/5. This is a top-heavy fraction, an improper fraction, because the number on the top is greater than the number on the bottom. The numerator is greater than the denominator. Usually when we're giving an answer, or we end up with an answer that is a top-heavy fraction, in maths we would usually change that into a mixed number and present our answer as a mixed number. So I'm just going to change 12/5 into a mixed number, 2 2/5. Just a reminder of how I did that. I look at the denominator. How many 5s fit into 12? There would be 2 5s with 2 left over. So 2, remainder 2, and my denominator does not change. So how many 5s are in 12? 2, remainder 2, and my denominator does not change. So 3 times 4/5 is 2 and 2/5. Okay, we're getting a little bit more complicated this time. Remember, you have the ability to pause the video at any point, so if you want to go ahead and answer the questions yourself before I explain my workings, then you can, of course, do that. So I've got a mixed number times a fraction here. 2 1/4, 2 1/4 times 2/5. Again, I'm just going to manipulate the question slightly, so I'm going to change this mixed number into a top-heavy fraction. So I'm going to do 2 times 4, which is 8, and add that on to the 1, which is already on my numerator. So 2 1/4 becomes 9/4. 2 times 4 is 8, whole number times denominator is 8, and then I add that onto the numerator that's already there. That's where this 9 comes from. And again, now we are being consistent with the method we've used in the previous questions. 9 times 2 is going to give me 18, and 4 times 5 is going to give me 20. So there's confirmation of the calculations I'm going to do. And then I'm left with 18/20. We're not dealing with a top-heavy fraction this time, but we are dealing with a fraction that can be simplified. 18 and 20 are both divisible by 2. So I'm just going to simplify them down and end up with 9/10. So the answer to this calculation, after I've shown a few steps of method, is 9/10. Just going to have a look at a couple of division questions this time. So now I've got 3/4 divided by 2/3. So I want to know how many 2/3 fit into 3/4. We have a method for dividing fractions which involves flipping the second fraction upside down, or mathematically speaking, finding the reciprocal of 2/3. So I'm going to flip this fraction upside down. You may have heard this method referred to as keep, change, flip. So I'm just going to manipulate my question to look like this. Keep, so the 3/4 remains the same. Change, so the division sign now becomes multiplication. And flip, so 2/3 has been flipped upside down to become 3/2. Mathematically speaking, I've found the reciprocal. What flipping the second fraction does is it gives us a shortcut to finding a common denominator. We could have went ahead and found a common denominator over here by cross multiplying, but just a shortcut to miss out that step is to flip the second fraction and change your sign to a multiplication sign. So mathematically speaking, we are cross multiplying to find a common denominator. But what you need to remember in terms of your notation and presenting your answer in an exam is keep, change, and flip. So now I'm going to go ahead and answer this as if it was a multiplication question. 3 times 3 is going to give me 9. 4 times 2 is going to give me 8. So I'm going to be left with 9/8. This is a top-heavy fraction because the 9 is greater than the 8. The numerator is greater than the denominator. So I'm just going to change that to a mixed number. How many 8s are in 9 would be 1 remainder 1. That's where my answer comes from here. 1 whole, and 1 is the numerator, and the denominator stays the same. So 3/4 divided by 2/3 is 1 1/8. How many 2/3 fit into 3/4? This is how many. 1 1/8. Okay, another example from me. So this time we're getting a little bit more complicated. A very typical exam question here. When you're given a question like this and you're asked to show each step of your method to get your final solution. So you're asked to manipulate the fractions, to work with the fractions, showing your method at each step. So first thing I'm going to do here is I'm going to change this mixed number, 3 3/4, into a top-heavy fraction. 3 times 4 is 12. Added onto the numerator is going to give me 15. So I'm just going to change the question slightly. So I've changed this mixed number into its equivalent top-heavy fraction. 3 times 4 was 12. Added that onto the 3, give me 15. 15 over 4. So now I'm dealing with a division question. I'm going to go ahead and keep, change, and flip. So I'm going to find the reciprocal of 1 over 5, which will be 5 over 1. Remember, mathematically what we're doing is we're doing a shortcut of finding a common denominator, a shortcut of cross-multiplying. So my question, after keep, change, flip, now looks like this. 15 times 5 is going to give me 75. 4 times 1 is going to give me 4. So how many 1/5 can fit into 3 3/4? Well, the answer to that is 75 over 4. This is a top-heavy fraction, so just to get my complete and finished answer, I'm going to change it to a mixed number. How many 4s in 75? And then whatever my remainder is will go on the numerator. How many 4s in 75 is 18? That takes me up to 72, and then I have 3 remaining, so I'm left with 3/4. Denominator does not change. So how many 1/5 fit into 3 3/4? Well, the answer to that is you would have 18 3/4 1/5 fitting into this value. So now it's your turn to have a go at a few questions. I've put on the screen a set of multiplying fractions questions. They increase in complexity as you work through the questions. For each question, could you show me your full working out? Could you show me your full method, your notation of how you got the correct solution? In your test or exams with fraction questions, they will always ask for a full written method. So if we could try and have a go at all 9 questions, if you could pause the video at this point, show me your full working out, and have a go at the questions A all the way to I. Could you pause the video now, please? Okay, welcome back. Just going to go ahead and show you my solutions. So you can see the range of questions we're dealing with. We have an integer multiplied by a fraction. We have some top-heavy fractions included. We have some mixed numbers included. We have a question here involving 3 fractions. So again, just a range of different approaches, different questions that you may get asked in your tests or exams. As you've worked through the 9 questions, your solutions should look something like this. So just spend a little bit of time marking and assessing your own work, making sure that you have simplified your answer if possible. Okay, so we focused on some multiplication questions there. In the next task, we're going to have a look at some division questions. Here is the last task for you to have a go at. So I've just selected 3 very common GCSE fraction questions. You can see in each question that it already gives you the solution. It already gives you the answer. So it already tells you what you're aiming for. So your marks, your 2 marks or your 3 marks, They are awarded for your method, for your notation, for showing the examiner how you got from the original question to the final answer. So that might include changing from a mixed number to a top-heavy fraction. That might include keep, change, flip. That might include simplifying fractions. Whatever you do to manipulate the question, to manipulate the fractions, you need to show that to pick up the full marks. Okay, could you pause the video at this point and have a go at the 3 exam questions? Okay, welcome back. Just have a look through my solutions. This is what my working out looks like. So you can see that I've tried to show you the full method of how I ended up with the answer that the question already gave me. So in question 1, we've incorporated keep, change, and flip for 1 mark, but also the answer we end up with, 24/45, that needs to be simplified. So your second mark there would be for the simplification. For the 2 questions at the bottom, again, you can see my full working out. For this question, I've started by changing mixed numbers into top-heavy fractions and then continued with the keep, change, flip method in order to get my solution. Again, this fraction of 30/96 needed to be simplified down. And for question 3, you can again see my full working out. Take a minute or so to mark and assess your work, making sure that you've shown each step of your method to pick up all available marks. Very well done if you were able to correctly answer the previous 9 questions on multiplying fractions and also these 3 questions on dividing fractions. So if you were able to give all 12 questions a good go, then that is excellent. You've shown a very good understanding of this topic. Well done.